Hey all! I've been working on a new large update, and one of the things included is what you can see here, which is a new example map, which is located in Maps and Sci-Fi, and it's called Jungle Raid. And the first thing you'll notice about this map is that it uses a lot of assets that are not just placeholders. So these are all Creative Commons assets that were provided by user Invols on Reddit, and these are Creative Commons 0, which means that they can be used in any commercial project free of charge, and you don't even have to attribute the creator, though I still think you should, of course. And these are absolutely amazing and makes it possible to create an example map that looks more like an actual game compared to the other example maps in the toolkit. So that is a fantastic gift to everyone, and there are quite a few of these models are included in the new update, though there are more of them in the Reddit thread, which I will link to below. Now these skeletal meshes, they were not rigged already, so big thanks to user Bankworthy on the Unreal Engine forums who rigged these for me. And in addition, these icons are from gameicons.net. These are Creative Commons, but they require attributing them if you are going to use them in your games. So those are from Game Icons. I will link to below, and also you will see the credits for the actual creators of the specific icons in the description below, so please do that. Now, let's explain a bit of what's going on here. So there are a ton of new features here, as you might be able to see. We have, of course, one of them is that you have this move distance and run distance. Also there's cover, so you have full cover for large objects and half cover for smaller objects. You have various skills that you can choose here, either from the menu or by pressing the keys on your keyboard. The skills I have included are sprinting, which is basically move, but with this two-tiered system that you can move a certain distance, and then after that you've used one action point, so you can run and then your turn will end. Also there's the laser rifle, which is like the basic attack skill, and Overwatch, for those who've played XCOM, this is if you press Overwatch, your unit goes into Overwatch mode, which means that the moment he spots an enemy unit that moves within a line he has attack range to and sight, then he will attack that unit on that unit's turn. In addition, the explosive shot, which fires an explosive projectile that damages several units in an area. And you can also see here that I've added the option of having a limited number of this type of item. You can also see that you can, now he spotted me. That's another thing too, that in this example game, all the enemy units, they don't start being in the initiative order array, so they are not really in combat until they spot you, which happened here. Or if they hear a sound, so if you shoot someone next to them, or fire an explosive somewhere and so on, then that will wake these units up. But yeah, where was I? So now this is another unit that I selected, so you can swap back and forth. You see that he still uses action points, so he has one action point remaining. And this guy has the same skills, so he also has a med pack for healing. And then you have the final one here. Let's see. I put 2 medics actually. Yeah, so there's also a mind control ability, but that's only on the enemies in this example map. Now, let me just show you how this works. So we can move into cover. That means that there's a lower chance of hitting. In this example, you also have included stuff like accuracy and so on, so every attack is not an automatic hit. And then I choose the laser rifle. I have visibility to this guy. You can see here down in the HUD that there's a hit percent chance and a damage. He is in a light cover, as you see here, so it's quite hard to hit him, but I will try. Then I fire a projectile, a laser, and this guy is alerted because he has line of sight, so does this guy, to where his friend was hit. And it keeps going like that. Let's see, I don't have anyone in grenade range, so I'll just put this guy in Overwatch. This guy, I'll just put him in cover. And the medic, I'll put him over here in Overwatch. And this medic too. There, let's see. So when this guy moves and he is spotted, we missed him in all cases. That was bad luck. Yeah, and he fires down here. So one of the things that comes with these skills is an advanced AI. So you can see here that this enemy unit, he chose to go into cover, and he chose to use an area attack because two of my guys were bunched in here together. So a part of this skill system is that every single skill has a unique node structure, blueprint node structure, for the AI, which helps them decide which of their skills is the best skill to choose for any specific situation. So in this case, he chose this area where he had the ability to attack these guys, and he was in cover as well. So just to show off the heal skill here, maybe not the most tactically sound thing to do, but yeah, I can then move in cover and also use an explosive shot of my own. There we are, and this alerts more people because it's quite noisy. But yeah, I guess you get the general idea of how this works. So here's the folder structure of this new example map. As you can see, it's located under Advanced Turn-Based Tile Toolkit, Maps, and Sci-Fi. And no assets that are in any other folders are dependent on any of the assets here. So to free up space when you're making your own game, just delete the sci-fi map here, and then that should no longer be an issue. So here you have the various audio, blueprints, characters, and so on that are used in this map. So the most interesting stuff you can find here under blueprints, where you'll find the new variants of the game modes, AI controller, player controller, and so on, that are built upon the base player controller, game mode, and so on from the base toolkit, but with added functionality. So you're free to look into those and see the code there. In addition, here are the new units. So you have this new unit skill base, which is derived from the unit parent class, but has a few different options. If you select one of these units here, in this case the medic, which is based on the unit skill, you can see that it has a few other values like accuracy, chance of hitting, dodge value, and also it has skills. So there is an array here of all the skills that this unit can use. And the skills are located in the skills folder, which are all based on this skill blueprint. So here you can see the layout of the event graph of the base skill, which all the other skills are based on. So all of them function kind of both like the player controller from the base toolkit and as the AI controller in a sense, though both of them are initialized from the player controller and the AI controller. So for all of these skills, they have a begin play part, which basically just sets up all the references. It also has its own unique skill marker, a skill decal, and so on, connected to each separate skill. It has this activate skill custom event, which sets this skill as being like the current skill of the active skill of the current unit, enables the tick of the skill, so on. So the thought is that all of these skills are spawned at the start of the game as child actors of the various units, and then they are inactive for most of the time unless they are needed, in which case you run activate skill, which kind of opens up everything else. It enables the tick so that you can get the hover mouse events. It sets it as the active skill so that when in the player controller you choose to click something, then it will look at the active skill and activate the, let's see here, the tile clicked event here. And also there's a tick, like I said, which is for updating the hover index and so on, and how the skill is displayed when it is active. And also, in addition, there's this AI check value custom event, and this is important for the new AI system, where at the start of its turn, each AI unit will go through all of the skills it has, and for each of them it will check its value. And what this means is that it will try to assess, okay, what enemies can I reach, which tiles can I move to, and so on, and they will assign a value on each of those based on custom events within the skill, and then it will choose the skill which has the highest estimated value. There are also quite a few custom functions within the skill for various things. So for like paying the action point cost, for modifying the AI priority, getting the text that is supposed to be displayed when you're hovering over the skill in the UI, and these are various AI things like finding what potential targets can I reach, which target candidates within these can I actually reach, find the best possible reachable target based on various values, and so on. But all of these are specified more inside the various specific skills. So let's look at one of those skills to give you a more concrete example of what is going on here. So this is the laser skill, or skill laser, and here you can see how the functionality is extended, and it's quite extensive actually. It takes a bit to set up a skill working properly, though you can use quite a few of the same functions for many of the various skills, since many of those are contained in the skill blueprint itself. So if you can see here, activate skill, so this is activated from the player controller when you are activating a skill, or from the AI controller at the moment when the AI chooses to actually use this skill. And then you have all the base stuff, of course, from the parent, from the regular skill blueprint, and then other stuff happens depending on whether the unit that activates this skill is AI controlled or not. And this is where it splits up into something that resembles a bit more the player controller, and something that resembles a bit more the AI controller from the base blueprint, in a sense. So to look first at the player, so if it's the unit activating this is not AI controlled, in this case we will just zero out the pathfinding. So for the laser skill, we don't want to show any of any tiles in move range. We just want to find visible units in range, and then spawn tiles so we can see what units we can hit, and then setting the HUD text. And then when the skill has been activated through this and the unit is player controlled, you will be able to fire off the tile clicked event. So this is called from the player controller, and then when you're clicking a tile for this skill, you will check, okay, is there a unit on this tile? So is this unit in the tiles in sight array? If so, then we pay the action point cost and we fire the attack unit custom event. And at which point a lot of stuff happens. So we set the target based on what we click, and we move the camera between the two units. We pan over to the middle of the two so that we are likely to be able to see both units. Then we check if the attack hits using this calculate hit chance function. We fire the animation, all of that stuff. We wake up any units that can see the target being hit or can hear us shooting, and then we deal the damage. And then deactivate the skill, which should always be called at the end of a skill. So that's like the general, how it works in general for a player activating this laser skill, and it will be similar for other skills as well, though other skills are very different, of course, like Overwatch. Now if it is an AI unit, we do some other stuff instead. Then we first check, okay, does the AI unit have enough action points to both move and use the skill. So in this example, all skills are set up for the AI so that it both looks at the skill itself, but it also looks at what possible tiles can it move to use this skill from. And this is especially important since there is cover included here. So if it does have 2 or more action points, which will actually be the case here if it doesn't have exactly 1 action point. I should maybe have made that clearer when it comes to think of it. So this should be greater than 2, we should go here, but yeah, it works the same anyway. And you can see here the check value part, it runs the same nodes as when the AI is activating the skill. So in this case, it kind of simulates and sees what is the best thing it can do, but it doesn't actually execute it because this only check value variable is set to true in the parent AI check value. So if we activate from here, then it will just run through everything and simulate and then set an estimated value that it returns back to the AI controller. While if we have actually activated the skill as an AI, it will go through the same nodes and then it will find the path and initialize movement and activate the skill and so on. So all of these skills for the AI, they have the basic setup here that it first it evaluates the skill and then it finds the tile from which to use the skill. And there is a lot of stuff inside this here again. So if we go to evaluate skill, then we go back to the skill blueprint, and this is has a few more functions. It finds potential targets. That means what targets could it possibly reach. It looks at the maximum of its move and the maximum added together the range of the skill and its move. That's the if any unit is beyond that, it can't be reached, right? And then from all of these, it finds, okay, which of these units are in sight from the move array. So from the tiles it can move to, which of the potential targets here can it actually reach? And then from all of these, it then determines, okay, from all of these, which is the best target? And this is decided within each skill. So so this function is generally modified inside the specific skill blueprints. In the case of the skill laser, if we go to the find, actually it doesn't, there's in this case, so in find best target, you have this function here, and it loops through all the potential targets, and for each of them it checks, okay, what is the value of attacking or using this skill on this target, and adds it to a choice array from which it chooses the best possible target. And this is the function which is generally modified within each specific skill blueprint. So if we go to skill laser and find the target value, we find that in the case of the laser skill, how we determine the value of a specific target is that we find the distance between the two. So it has a higher priority for units that are closer. And it also checks, okay, how much damage do I do? In the case of the laser, this is a damage range, so it has a minimum and a maximum range. And it finds out, okay, it determines if I'm certain to kill this unit if I hit it, then we give it a value of 1. If I might, it is I will not if I do the minimum value, but I will if I do the maximum value. Then I set a 0.5 value. If it will not kill it, just hurt it, then we set a 0.3 value, so it's a lower value. And this is the value that is returned in this case. So it looks at all the potential targets and sees, okay, if it's very close to me, then I consider it a bigger threat and assign a higher value to it. If I'm likely to kill it, then I will also set a higher value. After evaluating the skill and setting like the best target, then it looks at all the tiles you can move to and finds the best tile from which to use its skill on the best target that it has found. And this is also within the skill where it finds the best move index based on cover and based on the active skill. So what this means is that it loops through all tiles that it can in move range that have sight to the target. And for each of these, it then finds the priority value. This is something that is determined by the specific skill. I'll get to that. And then it decides the final target from viable options. I won't go into the specifics of all of this. That's not the point of this video, though just to give you a general idea of how these various skills work. So take a look into these functions yourself and let me know in the comments or the forum thread if you have anything you need specific help with. But that's the general idea, that first, like I said, it evaluates the skills, finds the best target, then after it has found it, it finds the best target from which to use the skill from. If it's not just checking the value, but it is actually using the skill, then it finds path and initializes movement to get to the best tile, and then after movement it will activate the skill again, and at this point it will have only one action point when it will prepare and execute the skill, which you can find up here. And in the case of the laser skill, it's a bit complex because it also looks at the Overwatch skill and finds out, okay, from the tile I'm standing on, is it a better idea to use the Overwatch skill, which is based on the percentage chance basically to hit its target. And it does all of this. If it decides to use the laser skill and not Overwatch, then it runs the same attack unit custom event as a player would when clicking on a viable target. So that's that. The other skills work similarly. Just take a look in those. I've tried to comment them fairly well, so just look at that if you're interested. In addition to the skills, we have this status effect, which is something that is applied to a unit, as say if it is mind controlled in this case, if it is in Overwatch mode, if it has woken up, has just been woken up from seeing a unit. These are various status effects. It can be anything, that if a unit is poisoned or something else, it would work too. So this is an actor that is spawned when a status effect is applied to a unit and added to an array within that unit of status effects. And at the start and at the end of a unit's turn, it checks the event, or it runs custom events inside the status effect, depending on whether it is the start or the end of the unit's turn. I'll give you an example, or I'll show you the base status effect first. So you have at the beginning of play, the status effect sets up references, and it has these events for what happens when the status effect is activated. So when it's first applied, and then it has these events on unit turn start, then it does any code you would set in between here, and then it runs this status effect checked event. So this is run from the game mode, or the specific game mode for this example game, which runs through each of the status effects and then waits until it has been checked, at which point this messages back to the game mode, okay, we have checked this status effect, go and check the next one, and it will check through all the status effects in the status effect array of the unit until it is done. The same thing happens at the end of a unit turn. So in this case you can have different effects that happen on the start and the end. Perhaps you want poison damage to be applied at the end, say, or perhaps you want at the end of a unit's turn at which it has been mind controlled, the mind control should end, or whatever else. So I'll give you an example of one of the specific effects. So this is the event graph of the mind controlled status effect. Though to explain this I should first go to the mind control skill, which is different. The mind control skill is similar to the laser skill in many ways. It has this AI part and also like this player controller part. After a player has clicked a tile with an appropriate unit, or after the AI has decided to use this skill and uses it on an a unit, this mind controlled unit custom event will be called, which spawns a status effect mind controlled actor, and the controlling unit variable, which or unit reference, which is a specific variable in the mind controlled status effect, is set to be the same as the unit which used the mind control skill. So we have a reference to the unit that did the mind controlling, so to speak. And then we activate the status effect, and this is some stuff just to work with the waking up of sleeping units in the example game. So it activates the status effect, it sets the controlling unit, and so on. Then on the turn of the unit that is mind controlled, it sets the old allied faction. So it stores what factions were your old factions, so that we can reset them after mind control has ended. And then it sets the allied factions of the mind control unit to be the same as the allied factions of the controlling unit. And it also stores, okay, before it was mind controlled, was this unit AI controlled or not, so that it can remember that, and then it is set to AI controlled to true. So a mind controlled unit will always be controlled by the AI in this skill. Then it plays a sound, sort of mind control sound I made, and it spawns this special effect, which I got from the Infinity Blade asset pack, which is available for free in the Unreal Engine launcher for those who are not aware. Then on the end of a unit's turn that has been mind controlled, it sets its allied faction back to be what was stored, so what it was before, and it sets its AI control to be the same as it was before, and it removes this effect from the unit's list of active effects, and it deactivates the status effect. So this is just one example, and you can follow similar recipes for making your own status effects. That could be anything really. Okay. Now I don't plan to go into everything in excessive detail here, just to give you an overview. One last thing I should look into or show you is the HUD, which is like fairly basic. So this is the info HUD, that is like the main HUD, which or the main widget within these other widgets are nested. So let's start with that. Here you can see the layouts, and within this then you have the various skills. Yeah, actually this is the second level in the nested hierarchy, come to think of it. But yeah, so within this the event graph of the HUD info, at the start of a unit's turn, the HUD or a player unit's turn, the HUD is updated to reflect the skills of the current pawn. So it just loops through them, and it sets up the various skills, these skill widgets here, to reflect the skills of the current unit. And it also sets up a reference in each of these to the skill child actors that are placed in the level. And then within the skill widget, also see the layout here, and it has a reference to the skill number, the image, and so on. And it also has a reference to the child actor with a specific skill. And in this widget, you have just some events when leaving or entering, like hovering over the skill. This is to set up the text correctly, but it's also because I've added edge panning, so you can hold your mouse at the edge of the screen to pan, and this also cancels this out while you're hovering over a skill. Then you have when you're clicking a skill, you're casting to the player controller, disabling its input, because from now on we want to get just have input to the as long as the player controller input is not disabled, we are allowed to activate the skill. That's what I meant to say. And then we get the skill reference, and we cast to the skill and activate the skill, basically, and then set the text as appropriate from getting the hover text of this skill, which is a function that is contained in all skill blueprints. So that's the general idea of how that works too. So I hope that's enough info that it's useful without being excessive. So feel free to play around in this map, and I hope it's fun to play too. I mean, it feels more like an actual game than the other examples here. Let me know if you have any questions, either in the comment section below or in the my preferred place, which is the dedicated forum thread on the Unreal Engine forums, which is also linked to below. Now, worth noting is that all of the features included here are not necessarily something that can be used with all other features of the toolkit. Now, this is the thing with the example maps I'm making, is something I do so that I can more quickly show features that are useful for specific genres and so on, that might not be useful in all different sorts of turn-based strategy games. So in this case, I want to make something like XCOM, like a tactical game sort of, and these features are useful for that, but in other turn-based strategy games they might not be used at all, which is why I don't include any of this stuff in the base toolkit. So the way I recommend implementing this stuff is looking through it, using what features that you think are useful, modifying stuff. You can also modify the base blueprints and just copy in the stuff that you think is needed and so on. You can't build directly upon this stuff too, and it should work fine, of course, but I'm mostly thinking of this stuff as being an example of one way of doing it, or being an inspiration of how you can use the toolkit to make various sorts of games. And I hope it serves that purpose. There are a lot of features here that people have been asking for a long time, so I hope that you will be happy, and thanks again to Involves and Bankworthy and the people over at Game Icons, which provide the stuff which makes this game example look so much better than it would have otherwise. It's just fantastic for those of us who are more focusing on the coding part to have these sorts of assets available for use. So thanks again for that. And with that, I think that's enough for this video. So see you guys later.